Hey everyone, my name is Suvesh Sant and I will be presenting on the topic Firewall Types and Architecture. So first to begin with are security enhanced and security focused protocols. So there are two types of security enhanced protocol extensions. One, telnet protocol such as remote terminal access and secure telnet, and two, remote procedure call protocol such as secure RPC authentication. Here we have security focused protocols. So these are two examples of security focused protocols, which are secure electronic transaction or SET and secure HTTP. So SET was originated by Visa and MasterCard as an internet credit card protocol, which basically supports the authentication of both sender and receiver and ensures content privacy in an effort to reduce merchant fraud on public networks. And secure HTTP is basically an extension of hypertext transfer protocol, which allows secure exchange of files over the internet or World Wide Web. In this case, SHTTP file is either encrypted or contains a digital certificate or both. Now these are other security focused protocols which are used in today's technology, which is Secure Shell, SSH, to secure socket layers, and simple key management for internet protocol mostly. One thing to note is that both of these protocols operate on the application layer of the OSI model. However, these three protocols operate on the transportation layer of the OSI model. SSH is a strong method for performing client authentication because it supports authentication, compression, confidentiality, and integrity. SSH is used frequently on the internet. SSH has two important components, which is RSA certificate exchange for authentication and triple DES for session encryption. Secure Sockets Layer, or SSL, is an encryption technology that is used to provide secure transactions such as exchange of credit card numbers. SSL is a socket layer security protocol and is a two-layer protocol that contains SSL record protocol and SSL handshake protocol. Similar to SSH, SSL uses symmetric encryption for private connections and asymmetric or public key cryptography for peer authentication. And next we have SCIP, a security technology that provides high availability in encrypted sessions. For example, crash gateways. SCIP is similar to SSL except that it requires no prior communication in order to establish or exchange keys on a session-by-session basis. Therefore, no connection setup overhead exists and new key values are not continually generated. Firewall types and architectures. Here we'll be looking at the different firewall types. So the first type of firewall we'll be looking at is packet filtering firewall. This type of firewall examines both the source and destination address of the incoming data packet. The firewall either blocks or passes the packet to its intended destination network, which is usually on the local network. The firewall can then deny access to specific application or services based on the access control list, which is basically a list of users and their access level. Here we have an example of how the firewall protects your home network. Basically, the router would receive information from the outside or the internet, and it would check through its access list to know whether the source IP address is allowed or not allowed to deliver its packets to the designated computer. So this type of firewall system is considered a first generation firewall and can operate at either the network or transport layer of the OSI model. Application level firewalls. This firewall is commonly a host computer running a proxy server. This firewall works by transferring a copy of each accepted data packet from one network to another, thereby masking the data's origin. This can control which services a workstation uses, and it also aids in protecting the network from outsiders who may be trying to get information about the network's design. This type of firewall is considered a second generation firewall. It is also called an application layer proxy and is commonly used with a dual homed host. It operates at the OSI protocol layer 7, the application layer. One drawback of this type of firewall is that it reduces network performance due to the fact that it must analyze every packet and decide what to do with each packet. A variation of the application proxy firewall is also called a circuit level firewall. Like an application level firewall, this firewall is used as a proxy server. However, this firewall creates a virtual circuit between the workstation client, destination, and the server host. It also provides security for a wide variety of protocols and is easier to maintain. So another type of firewall is known as stateful inspection firewalls. In this firewall, data packets are captured by an inspection engine that is operating at the network layer. It maintains a state table which is constantly updated. The packets are then queued and then analyzed at all OSI layers. This boosts performance over the pure application level firewall and also provides a more complete inspection of the data. By examining the state and the content of the incoming data packets, it helps to track the protocols that are considered connectionless, such as UDP-based applications and remote procedure calls. This type of firewall is used in third-generation firewall systems. Next, we have dynamic packet filtering firewalls, which is a fourth-generation firewall that enables the modification of the firewall security rule. This type of technology is most used for providing limited support for UDP. For a short period of time, the firewall remembers all the UDP packets that have crossed the network's parameter, and it decides whether to enable packets to pass through the firewall. So kernel proxy is a fifth generation firewall architecture that provides a modular kernel-based multi-layer session evaluation and runs on the Windows NT executive, which is kernel mode for Windows NT. It is a specialized firewall architecture that uses dynamic and custom TCP/IP based stacks to inspect the network packets and to enforce security policies. Unlike normal TCP/IP stacks, these stacks are constructed out of kernel level proxies. Now we move on to firewall architectures, and here we have packet filtering routers. This is the most common and oldest firewall device in use. A packet filtering router sits between the private, trusted network and the untrusted network or network segment, and is sometimes used as a boundary router. A packet filtering router uses access control lists. This firewall protects against standard generic external attacks. However, one problem with this type of firewall is the access control list can be manually difficult to maintain. This type of firewall has several drawbacks as well. It lacks strong user authentication, employs minimal auditing, and its complex ACLs negatively impact network performance. This packet filter router is sometimes used to directly manage the access to a demilitarized zone network segment. Next, we have screen host firewall system. So this firewall architecture employs both a packet filtering router and a bastion host, and is called screen host firewall. It commonly provides both network layer and application layer services. This type of firewall system is considered safer because it requires an intruder to penetrate two separate systems before he or she can compromise the trusted network. The bastion host is configured on the local trusted network with a packet filtering router between the untrusted network and the bastion host. Because the bastion host is commonly the focus of external attacks, it is sometimes called the sacrificial host. Next, we have dual homed host firewalls. So this is another very common firewall architecture. It is also called a dual home or multi-home bastion host. This architecture is a simple configuration that consists of a single computer, the host, with two NICs. One is connected to the local trusted network and the other is connected to the internet or an untrusted external network. A dual home host firewall usually acts to block or filter some or all the traffic trying to pass between the networks. IP traffic forwarding is usually disabled and restricted. All traffic between networks and traffic destination must pass through some kind of security inspection mechanism. A multi-home bastion host can translate between two network access layer protocol, such as Ethernet to token ring, for example. A design issue with this firewall is that the host routing capabilities must be disabled so that it does not unintentionally enable internal routing, which will connect the two networks together transparently and negate the firewall's function. So one of the most secure implementations of firewall architecture is the screen subnet firewall. It employs two packet filtering routers and a bastion host. Like a screen host firewall, this firewall supports both packet filtering and proxy services, yet it also defines a demilitarized zone or DMZ. This creates a small network between the untrusted network and the trusted network where the bastion host and other public web services exist. The outside router provides protection against external attacks, while the inside router manages the private network access to the DMZ by routing it through the bastion host. This provides more layers of security. However, one issue with this firewall is its complex configuration and maintenance. And the last firewall protection is provided by a firewall called SOX server. This is a critical level proxy server that does not require a server's resource overhead or conventional proxy servers. It does, however, require proprietary SOX client software to be loaded on every workstation. This firewall is mostly used for outbound internet access by a workstation. The problem with this type of firewall configuration is that it is support intensive due to individual workstation configurations and use proprietary software. Thank you for watching, and I look forward to your questions.